So here is the concept of this question. The very first question: at what height above the ground will the bob potential energy half of its kinetic energy? So the ground point, let's say A point, from A point at certain height, we don't know actually that height, that we have to calculate. Anyways, that is actually h. Beg your pardon, because the color is not. So let's say this is h, and at this height, at some certain point where the potential energy EP is equals to half of EK. This is the condition for the very first question, and what we have to calculate, we have to calculate the value of h. And here, important point: at h height, of course, the total energy at h height, some sort of point, maybe this point, maybe this point, we don't know actually. So the total energy at h height, EP plus EK. So total energy is equals to potential energy and the kinetic energy. Or we could write down EK is equals to E minus EP. Now the important task is to find out the value of EK and EP as well. Indeed, what we have to calculate, we have to calculate the height from A to M and M to N. This type of height we have to calculate. Anyways, so at B point, the kinetic energy half mvb square. So vb square is equals to, so at C point, vc is equals to 0 meter per second. So here will be 2g and height is mn. And here we forget to tell you that the height of the string, it means that P to A or A to P, P to C, P to B is 30 centimeter. That is given at question. So VB square is equals to 2G MN. And at B point, EP is equals to mg. So at B point, the potential energy, what we need to have, that the height am. So here will be am. So from the condition, what we have, E equals to EP plus EK, or EK is equals to E minus EP. So if, let's say, at certain point H represent the M point, indeed at B point, the total energy subtracted from total energy to potential energy equals to the kinetic energy, right? And the condition we have, that is EP is equals to half of EK. So here EP is equals to mg, let's say am is equals to h, that we have to calculate. And here half EK represents E minus EP, so E minus EP. So this is the total energy. So total energy represents mg h. This uppercase H represents the total length of the string, which is 30, and EP is mgh. So let's simplify and solve the equation for h. So here will be 2 mgh plus mgh equals to mg. So uppercase H means 30. So here will be 3 mgh is equals to mg 30. From both sides, mg cancel out. So the height h is equals to 30 over 3. So 10 meter. So at h equals to 10 meter, the condition was the potential energy is equals to half of ek. So this is the answer for first part. And second part is, if mathematically, if the if the mechanical energy at point A, point B and point C is same, it means it conserves the postulate of energy conservation law. We have to analyze this concept in mathematically. So we have to determine the total potential at A as well as B and C. So at A point, the total energy E is equals to EP plus EK. So let's write down here A because it is at A point. So at that point, there is no velocity, so it will be 0. And here will be mg, and the height is am, right, at C point. So it need to be write down A and M. So we could write down mg A M. Actually, at C point, the height is an. It should not be. So it will be an. It is an. So total energy is an joule. We don't have the idea of the height of an. Anyways, for B point, the potential energy for B point is equals to mg am. Let's check out. So at B point, the height is up to this much. So this is actually am. So here am is perfectly okay. And the kinetic energy is half mvb square. So vb square, did you calculate somewhere? Yes, that is actually 2gmn. So vb 2gmn. So let's write down here half of m dot 2gmn. Now the total energy at B point is, here we can do one thing, 2 cancel out. So here mg am plus here mg mn. So here mg am plus mn. So am plus mn. So let's use the red pen. So here up to this much is am, and up to this much is mn. Altogether we could write down an, right? So here we could write down mg an, same as for point C, point A actually. Now it's time to calculate the point C. So at point C, actually we made a mistake. So this will be actually point C. This is actually point C and B have done, and this will be point A. So for point A, it means at this point, there is no EP exist, right? There is no EP exist. It means that here, so it's time to determine the value of A points, the total energy, right? So total energy at A point is equals to EPA plus EKA. So EPA means mg. So at A point there is no height, it means it will be 0, and EKA, so EKA equals to half m VA square. So VA square means when it's traveling from B to A towards this direction, right? So at this point VA, so VA square equals to, it is coming from VB, indeed it will be VV square plus 2G, and how much height? It will be AM, and we already have calculated the value of VB square. Let's check out the value of VB square. So VB square is equals to 2GMN. 2GMN. So it will be 2GMN plus 2GAM. So 2G is common. So MN plus AM. So here AM plus MN. So altogether this is AN, pardon. So 2G AN. So this is the velocity of 2G V square V square A or VA square. So let's plug in the value of total energy. Will be total energy is equals to 0 plus E of Ka. So it can be written as half m then 2G AN. So 2 to cancel out, so it will be written as mg an, right? Let's write down clearly. So it will be an. So here at A point mgan, look at here, which is for B point, which is also same as mgan, so that we can write down that point A comma point B and point C, everywhere the total energy is same. So EA is equals to total energy, actually B is equals to EC. So if we write down here A, total energy, which is actually mgan, and there is another portion written to analyze that whether it is conserved or not. Yes, it is conserved, as at every point A, B and C, everywhere the energy is mgan. This energy is same for C, B and A, so the energy is conserved for this condition.